Hello everyone, welcome back to the another session in design and analysis of algorithms. Today we'll be going to learn about job sequencing with deadlines. This topic you'll find in third unit as topic number 4. This is also one of the problem where we can apply greedy method, and very consciously this problem is going to be your lab experiment. So whichever topic we were started with third unit, that are all experiments what you can find in your lab syllabus. Now let's get started to understand about what is job sequencing with deadlines. What is job sequencing with deadlines? We are given a set of n jobs associated with job I is an integer, deadline di greater than or equal to 0 and profit pi greater than 0. So here what we are going to do is we'll be given with some n jobs, that task. Each task will be having a deadline to get completed. So always this deadline will be what? Greater than or equal to 0. Now after we complete each job, we'll get some profit. That is what indicated with pi. Now what is our target is? What is the feasible solution to finish jobs in this deadline? So we need to find out the feasible solutions for this task. And for any I, the profit pi is earned if and only if the job is completed by its deadline. So if you completed job in the specific deadline, then only this profit will be earned. Now to complete a job, one has to process the job on a machine for 1 unit of time. So this thing we have to keep in our mind before we process job on the machine. So each job will take 1 unit of time, and the other constraint is we have only one machine to process all the jobs. Now feasible solutions for this problem is a subset J of jobs such that each job in this subset can be completed by its deadline. The value of a feasible solution J is the sum of the profits of the jobs in J, and that is sum of I belongs to J pi. That means when we completed the job in the given or in the specific deadline, then only we will get a profit. So for whatsoever job we get the profit, that is called as feasible solution. So once you have a profit, means it senses what? That you have finished that the job in the specific deadline. Now what is the optimal solution? Optimal solution should be a feasible solution with maximum value. So job sequencing is what? It is a maximization problem. It is a maximization problem, or it is an optimization problem. Optimization problem is a problem which have a result of either maximization or minimization. So as far as optimal solution of this job sequencing deadline is maximum value, then you can say it is a maximization problem. Since the problem involves the identification of a subset, it fits the subset paradigm. Now we'll see an example to understand a better way. In the previous slides, we do understand total 5 points that we will be given with n jobs. Each job is associated with a profit and deadline, and we'll be going to use a single machine. Each job will get completed in 1 unit of time. Machine will take 1 unit of time to get completed. Now assume that there is a computer. Now I have 3 different tasks to complete. Assume it. For the understanding purpose, I am telling you. So this is what one machine where we have 3 jobs. 3 jobs to finish using of this computer. Now it is very natural that you cannot finish all these 3 jobs on single machine in single slot. Correct? If it is true that system will take 1 unit of time to process each document, obviously we need 3 units of time. That means we take 3 slots. 0 to 1 is one slot, 1 to 2 is the other slot, 2 to 3 is the other slot. Now what machine will do is, machine will take this job to get completed in this slot, okay, or else this task can get completed in this slot, and whichever slot is free over here, that free slot is given to the other job to get finished. Now here problem comes with the deadline. Deadline is what? The amount of time till what time it will be wait. So assume that it is what? The deadlines 1, 2, 3 are specified as deadline. So this task is carried out by some P1 person, some P2 person, some P3 person. Now P1 person can wait only 1 hour, P2 person cannot wait for 2 hours. So as he can wait for 2 hours, then what we will do is, whoever person will not go beyond of 1 hour, first this job will get finished. Okay, so 0 to 1 slot is given for P1. Now so we have other thing, that P2 and P3. So P2 can get finished over here, P3 can get finished over here. So it is called as a feasible solution. Feasible solution is what? The solution which satisfies the constraint of the problem. So it is called as feasible solution. Now what is optimal solution? Optimal solution is a solution, it should be a feasible first of all, then the feasible solution which gives either maximum profit or minimum. If it is a maximization or it is a minimization, then you can say it is an optimum solution for a problem. Now this is what job sequencing with deadlines basic problem is. Now we'll take some example and to understand through the example. Now let us assume that I have given n equal to 4 jobs. Now I wanted to finish this 4 jobs, J1, J2, J3, J4 in the deadline. So the maximum deadlines are what? 2. That means our machine can take 1 unit of time to complete each. But so total 4 jobs, so machine can take 4 units of time. That means 4 slots it can execute. 0 to 1, 1 to 2, 2 to 3, 3 to 4. But I did not find any job which waits up to 4th hour. The maximum deadline is what? 2. So maximum deadline always indicates you the number of jobs what you can complete. So as it is at 2, that means what? I can finish only 2 jobs. So which 2 jobs we will finish? So that is what we will say as the possible feasible solutions. That is, the feasible solutions and their values are the feasible solutions and the value. Now as I told you, the slot is what? 0 to 1, 1 to 2. As I found it is the maximum deadline is 2, so I can complete only 2 jobs. Now which 2 jobs we will complete? So that is what? My first feasible solution and the processing sequence. If you see the title of this topic is job sequencing. That means process of sequencing the jobs, and the profit what we gained after we computed the jobs. Now let's see. First feasible solution is I am taking 1, 2. So this 1, 2 in the sense what? First job. Now let's see. So as far as I am considering these job, here I have 2 slots, but there are 2 who are waiting for the who are waiting for the turn to get completed their job. So I am picking this J2 as it can wait for only 1 hour. So first slot is given for J2. After that I am taking J1 to get complete because it can wait for 2 units of time. It can wait for 2 units of time and proceeding it. Now 1, 2. Now job processing is what? Whichever gives highest profit, that will be the process first of all. So that is 2, 1. Now the profit of this is what? 100 plus 10, which will give 110. The second feasible solution is what? 1 comma 3. That means I can go using of processing sequence 1 comma 3 or 3 comma 1. So 1 job profit is what? 100, and 3 job profit is what? 15. So 100 and plus 15, which gives me 115 as a profit. And still I can have a feasible solution. The feasible solution is what? 1 comma 4. That is, the processing is what? 4 comma 1. So now in this time I can have a profit of 127. Still I can go to have a feasible solutions 2 comma 3, and the sequence is 2 3, profit is 25. 3 comma 4, sequence is 4 comma 3, profit is 42. Now all these are what? Feasible solutions to complete this job in the given deadline. But what is optimum solution? Optimum solution should be a feasible solution which gives either maximum result or minimum result. As far as job sequencing with deadlines is concerned, it is a maximization problem. So whichever is having maximum profit, that is considered as optimum solution. Now among all this profit, which is having maximum? 127 is having maximum. That means we will take this job as solution, optimum solution for this problem. So this is what the example, and you can also take the other example. This example is having 5 jobs, and each job is corresponding with profits and deadlines. So as I told you in the previous example, the maximum deadlines will ensure you the maximum number of jobs what we can finish in the given deadline. So that means I can take 0 to 1, 1 to 2, 2 to 3. Now question comes into our mind, which slot I can give? This slot is given to which job? This slot is given to which job? So choosing of this slot of job can always will be decided based upon the deadline of the job. So now I can consider what job I am considering, and the slot what I am assigning to it, and the solution and the profit. Now solution is nothing but the sequence, job sequencing, processing sequence. Now I am taking initially all are null, right? Solution is 0, solution is pi, profit is 0. Now I am choosing J1. When I am choosing J1, in which slot I can finish this J1? J1 can wait 2 hours of time. So as it is 2 hours of time, I can choose this 1 to 2 slot for J1. 1 to 2 slot for J1. So I am writing the slot what I am assigning, which is 1 comma 2 slot. So what is the processing sequence? J1. What is the profit of J1 once if I completed J1? 20. Now next, this slot is empty, this slot is empty. I can make this slot and this slot for the other jobs where that is J2. So already 1 comma 2 is finished. Now before that slot which is having empty, 0 1. So I am taking 0 comma 1, 1 comma 2. Now this job sequencing is J1 comma J2. Now the profit is what? 20 plus 15 is equal to 35. So after J2, still I have one more slot what I can accommodate. Now let's see whether J3 can be included. If I include J3 is what? It can be it can wait till only 1 hour of time. So it is what? 3rd hour of slot. So obviously you cannot place this J3. Hence J3 is rejected for the reason 0 1 slot is occupied, 1 comma 2 slot is also occupied. So I can process only J1 comma J2 with the profit of 35. Now again select J4. So J4, see that one. J4 is what? It can wait till 3 hours of time. So I can accommodate this slot for J4. So J4 means 0 comma 1, 1 comma 2 and 2 comma 3. This slot is given for J2 and this slot is given for J4. So J2, J1, J4. So this lot, now the processing is J1 comma J2 comma J4. Now the value, profit value is 40. Now there is one more job which is left. If I consider that job, there is no slot vacant to accommodate this job. So naturally it is rejected. What jobs we accepted to get finished? J2, J1, J4. In which sequence we were? J2, J1, J4, right? J1, J2, J4 also, right? So these are the two job sequences. What are the solutions of this problem? So when you are asked to write a optimum solution for this problem, whichever profit value it gives you maximum, that is the optimum solution. That means J1, J2, J4 is the optimum solution of this problem. Thank you all.